The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, good afternoon, good evening, wherever you are, folks. I'm Krishna Vedula from UMass Lowell and also for Indo-Universal Collaboration for Engineering Education. We have an exciting webinar for you today. It's our ninth webinar. I was just talking to Ashwin. Wow, we've done so many webinars already. Fantastic, a good collection. This one is on big data and business analytics. What you will see is some exciting stuff from two of our senior faculty members, experienced faculty members at UMass Lowell. One is Dr. Luvai Motiwala and then there's Amit Devkar, both from the Management Information Systems at UMass Lowell. And so I'm going to hand this over to Ashwin Mehta, the coordinator of this program, so that he can tell you a little bit more about what you will see. So Ashwin, just click show my screen. Okay, go ahead. Yeah.
Hello, good morning or good afternoon, and welcome to our ninth webinar on entrepreneurship education. And as Professor Badula mentioned, we did 9 webinars this year. We have 2 more to go, and it's been a very exciting year for us. So it's been exciting as well as encouraging that we continue this for the next year, and we have a lot of plans for that. We'll talk later on that. But today we're going to have some very interesting topic to talk about. That's a kind of a must tool for entrepreneurs: big data and business analytics. We have 3 faculty members from our Manning School of Business: Dr. Matubala, Dr. Devkar, and Dr. Lee. We're going to talk about the big data and business analytics. So with that, I'm going to turn it over to Dr. Motiwala.
Okay, Luvai, I'm going to make you the presenter. Luvai, so you have click my screen in just a second. Click show my screen, and you're on. All right.
Go ahead. So I'm on. Hello, welcome everyone. It's exciting to be part of this entrepreneurship webinar series. As Professor Ashwin Mehta mentioned, we are all part of the Operations and Information Systems Department at Manning School of Business. And we are teaching this course on big data and business analytics, which has been a major innovation in the last 10 years and very popular topic among business and educators. So in today's webinar, we are going to split it up into 2 sections. Let me go to the next slide. In the first part, we'll just talk a little bit about what is business analytics and big data and how it can be applied in small business organizations. Also, why students should learn about this subject. And then in the second part, we'll talk about our programs and also different kind of programs which are available to students in US. So let me get started, and I hope all of you can listen to me, and you're all excited to start this seminar. So let's begin, and Professor Devkar will start with a little bit of background on what is BA, and then I'll take over in the middle.
Yeah, hello everyone. This is Amit Devkar. Excited to be part of this seminar. So let me jump in directly onto the topic at hand, which is business analytics. So when you think of business analytics, it's basically the idea is you're using data to solve business problems and gain business insights. And data analytics in general has become very popular over the past 10 or 15 years, mainly because of the growth in computing and data availability. So those are 2 real important factors that has driven the growth of business analytics. And what we are seeing over the past 10 years or so. So here's a article that was published in Harvard Business Review that back in 2012 actually, that said data scientist is the sexiest job of the 21st century. And what it really meant was while data analytics is starting to take off, we are seeing a lot of exciting applications in the business domain where businesses can make use of these technologies to drive the operations, bring in innovations, as well as ensure that the bottom line is is being affected in a positive way with this technology. So going to our next idea here about big data, when you talk to anybody about this term big data, it's a quite a loaded term, and it's quite heavy-handed. So different people would have different ideas about what it means. Well, when it was first coined as a term, people started characterizing it using what are called as these three V's. And really, just if you think about it, these three V's represent the volume, velocity, and variety. And I'll talk briefly about what each of this means. And so the first one here is volume. Volume implying that it's the size of the data that makes it a big data, right? The scale of the data. And so some examples that you encounter in today's world, whether you have a small company or a large company, is you might have access, your customers still would be, interacting on social media. They would be clicking on websites. Most of the stores, retail stores or companies have now a web presence in the past several years. So which means that the volume of data because of this availability of different platforms is increasing. That makes the one of the or is one of the characteristics of big data. The second one is the velocity, which means again going to the idea that a lot of data is becoming open and available. We are seeing data like customer data coming from social media, but also other open data sources like weather data, GPS data, which can be plugged into these or combined with other data sources to make useful predictions, right? So, for example, just to give you a quick idea here, a company could not only use their transactional data about customers, but they could listen to what customers are saying about their products in terms of sentiments and be able to react much more quickly in terms of how to make their product better or make any adjustments. And lastly, we have this variety, which really means that the data that used to be in tabular, nice and structured format, typically we could open in Excel spreadsheets and so forth, that is now becoming much more nuanced. I mean, we are seeing a lot of data which is in text. We are seeing a lot of video, audio, and that sort of data is very difficult to be analyzed with traditional tools. And so to be able to deal with this variety of data, the tools that are needed, the technologies that are needed are very different. So one thing I just want to clarify here is that when you say somebody talks about big data, it's not necessary that it has to have large volume, large velocity, and large variety, but it could be any one of those three things which makes it a big data. And just going to the idea of why so much interest in big data, again, I think there are two main reasons. One is that we are seeing a large growth in data, the availability of data, mainly also driven by mobile growth, right? So a lot of users are using apps which generate a lot of data. Wearables are becoming more popular, like Fitbit devices, those kind of things. And so it seems to us that, when you look at some of these industry reports, like the one here shown from McKinsey Global Institute, there is a lot of productivity gains to be made by using big data for innovation and also from a competitive advantage standpoint. Can you go to the next slide? So one of the ideas I was hinting at earlier when I used the term data analytics versus business analytics. So these terms might seem, somewhat different, but they are related. So data analytics is a more broader term, and it can be applied for any kinds of problems. And so here are some of these major societal problems that we, can be solved by using data analytics. Whether it's in the healthcare or in the sustainability domain, by analyzing, sustainable resources, energy resources, and also climate change related patterns, right? So a lot of these issues can be tackled using data mining and using data analytics as tools. Luvai, you want to add something here?
Yeah, what I was going to say, this slide shows an example that it's not data analytics and business analytics is not just to solve business problems, but we can also solve a lot of societal problems, help companies in their corporate social responsibilities, as we see in this example. So it has a wide application of use for business and non-business purposes. From farming to healthcare to all kinds of problems can be resolved because of the newer devices like Internet of Things, where you can, as Amit pointed out, wearables and other devices where you can track, things that are happening in the environment at every microsecond, and then start analyzing that data, figuring out patterns, and also looking at issues, problems, and trying to fix it by predicting certain issues, like in weather and climate change and things like that. For example, just last week, in health, no, in the climate environment, by tracking the ozone layer, they were able to figure out that the ozone layer is shrinking now because of whatever things that are happening in the environment. So these are some examples. Now, you want to, Amit, talk about this?
So what is shown here is just a couple of possible deliverables that you might see from a business standpoint, coming back to the topic of business analytics. So when you think of a typical business, you are perhaps as a lower, middle, or higher level managers, you are there to make decisions based on what is going on with your business, right? How many products are you selling? How many customers are purchasing things? Do you need to communicate with vendors? How many vendors? When? All kinds of things, which means that you have to rely on a lot of reports that are generated from different data that you can keep track of, right? So the assumption here is that you are somehow keeping track of data, perhaps in some spreadsheets, some databases, or some data source format. Traditionally, people obviously used to keep this in files and folders, but now, as I pointed out, things are moving at least to the electronic formats in some way, shape, or form. And now these tools like that used to be through Microsoft Excel as a beginning starting point, which is quite powerful actually to begin with, can you actually be used to create a report like this, which is shown here is a simple sales report. But there are also tools such as Tableau, which can create dashboards, which is the example of which is shown on the right side, that can generate interesting visualizations that can quickly help the managers be able to gain insights without actually having to navigate through a lot of or sorting through a lot of data themselves. So, for example, looking at this example on the right side, there is a very easy way to sort of understand, okay, well, the turnover by department from the sales department is in the sales department is much higher than, say, the R&D. You don't have to actually look at the numbers. So this visual understanding is a very powerful way of gaining insights into the data. So that is something that we try and emphasize in a lot of our programs, is how can we bring insights out that can be consumed by managers in a readily manner. And so that ability to use the data, but also to communicate it so that it can be used for decisions. That's really
just to add to what Amit is saying. What business analytics reporting does, it value adds by bringing visualized reports very quickly, so that managers don't have to spend so much time analyzing their Excel reports and quickly make decisions through visual observations through dashboard.
right.
Okay, So I had here an example, but I'll not go into that in interest of time. This is an example of our campus recreation center, which provides live data through dashboard in terms of the usage of the center, what times it's used more, who uses it. And so a lot of these businesses now, even small businesses, which are through their websites providing these kind of reports to their customers to help them make decisions. So let me just quickly go through why business analytics is important, since this is an entrepreneurship, program, and many of you are faculty teaching in this area. How big data can help small business. So lots of data is being collected and warehoused these days, as Amit pointed out, in terms of the volume and variety and velocity through a variety of devices, from wearables to in small business, the point of sale, the cash registers, POS. They're becoming much more smarter now with tablets and other devices. So all of that data is being collected, and then you can get data from external sources like Google and Facebook, social media. They provide that data. So what a lot of businesses are doing is combining their POS, the transaction data at the store, with some of these external data where customers might be talking about their product or services, and then integrating them to help them make decisions in terms of predicting what customers will be buying next, or what where will they spend their money in the next transaction when they come to their store. And also a lot of personalization, things like if you can provide a personalized environment for every customer, like Amazon or Flipkart does every time you log in. It shows based on your past behavior what products and services you might be interested in. The customer is more likely to execute the transaction and bring more sales for the business. So all of that information can be used by small business. And the thing is, all the technology with cloud computing and other platforms is becoming much more economical for small business to invest. There's a lot of focus on self-service data visualization solutions, where instead of buying Tableau or other expensive software, you can lease them on a monthly basis at a much cheaper cost from the cloud platforms like Amazon Web Services or Microsoft and others. Also, competition in small business is becoming much more, stronger. So, as I mentioned, personalization. So, through customer relationship management software, which analyzes a lot of data collected on the customer and the environment, can provide a better environment for the customers to be attracted to your products and services. Also, it can help in the operations area. You can do with analytics, better inventory management, better management of people resources, productivity, because it can keep track of all of your product and people resources and productivity rates, availability, and provide you in a dashboard format for managers to make good decisions. So let's talk a little bit about how this all is analyzed. So first we have to start with data, and data, as we said, is readily available, but you still need to organize it and make it, clean and accessible, because sometimes that data can be messy, it can be, in a different formats. So you may have to standardize it and make it available as its own. But that's your basic starting point. You need to have good data to make good business analytics. Then the different ways you can analyze this data is, one example is clustering. In a lot of business, you might have variety of customers, variety of products, and you want to see patterns of certain behavior in a customer or in a product. So one of the techniques which is used in data mining and business analytics is called clustering, where you try to cluster your data into groups or buckets. So then you can start, personalizing or marketing products and services to that group. Another example of business analytics is predictive modeling, where you try to uh, predict the behavior through a decision tree as it's shown. For example, in mortgage application, you may want to decide whether to grant mortgage to or a loan to a customer based on income, based on his past record, job environment. So you can use this kind of decision tree approaches to narrow down who to give this loan to or who not. Then a third technique that is commonly used is anomaly detection. This is where you try to figure out exceptions in your data, something unusual that's happening. For example, in banking environment, fraud detection. If every transaction is not going to be a fraud, only one or two out of several thousand may have patterns of fraud. So, for example, credit card companies will see certain behaviors and patterns in your transactions and highlight if some person is spending or using a POS in one region and suddenly it shows up in another region. That's unusual pattern because one person cannot be in two places. So the system will automatically detect and alert from the data as it's happening and try to prevent fraud. And then the most common one that's used in especially for business environment for marketing and sales is association. By looking at all the behavior patterns where customers are buying things, you may find that a customer who buys product X also buys product Y, and you can associate those patterns. The most common example was a few years ago in a grocery store where men would purchase on a constant basis Pampers, and they would also purchase milk at the same time. So you can associate that there's a pattern, and then grocery stores or even a small business can organize their shelves where they'll put milk and Pampers together. So the person who comes to buy, diapers or Pampers will always be attracted to buying milk because you've seen that pattern in past years. So these are some various ways in which business analytics works with the data. But as I mentioned, you need to have data and good data to produce all these nice results. Now, in terms of analyzing business analytics, there are three different models or three different ways you can analyze. Again, these are broad categories, and within each there might be various sub areas, but we will not go into all that. So three different ways you can analyze is known as descriptive modeling, predictive modeling, and prescriptive. In descriptive, it's mostly you gather and organize the data, clean the data, and then you describe the data. So the visual presentation example that Amit was discussing in the previous slides is an example of descriptive data showing all the different patterns of what's happening in the data currently. Now, tools like Tableau, Power BI, SAP Lumira, Excel could all be used for this basic, analytic model. Then you can go a little more advanced once you have started looking at the data and try to predict the behavior. So use past data to predict future. That's where you start using correlations and associations with the data variables, like the previous example, where a person buys Pampers, also buys milk, is based on this analysis. And then you can go even further and use some form of regression and supervised learning models to predict why a customer may respond better to a certain advertisement, for example. Based on past behavior, you can predict that this kind of advertisement attracts this customer by looking at all the ads in the past and how a customer behavior has changed based on that. Then a third kind of more advanced is prescriptive analytics, which not only describes or predicts, but also suggests the best course of action that you can take based on the data and past behavior of the customer. So a doctor prescribing medicine, for example, using machine learning and other tools can figure out for this diagnosis, this particular medicine has worked in the past and can suggest that course of action. So it uses cause and effect analysis. For example, in nursing, which actions are better for patients in terms of improving their health or behavior. And also you can control with some other variables by changing certain, removing certain examples and seeing which works better, A versus B, for example. Okay, so in terms of business analytic objectives, what are some goals and uses from an educator point of view? We are more focused on technical aspects, teaching students different technical issues to help them with business analytics, like you need to teach them statistics, a lot of data mining techniques, which I was showing earlier, forecasting, experimental design. These are some various methods you can teach business analytics to your students. As a user or a consumer, for example, a manager is more interested in how to apply some of these models to their problems. And as it says, descriptive is analytics will tell the manager what is happening. Predictive analytics, which we have discussed in the past, is going to tell me or tell the manager what is going to happen. While prescriptive is more about telling me what to do, what decisions to make, and how to progress. This next slide here is showing you how business analytics works. First, you need to, organizations today have a lot of raw data, but that raw data is, there are a lot of messiness and also missing and inconsistent data. So you need to transform that into more useful data before you can. So you take the raw data and put into some form of data warehouse or data mart, which is clean data organized in a certain way that you can use it for business analytics. Then from there, you can go into forecasting and predicting future customer behavior, or you can do data mining, searching for hidden patterns. You can use both of this forecasting and mining for decision making, making useful decisions for the next phase of planning or corrective action, and then finally improving your business strategy in the long run with collection of these decisions. Here we're just showing you in data mining what are some of the various high-level techniques. At the high level, you have two forms of learning that models can learn from the data, different patterns or prediction or whatever prescription that you want to do. One is called supervised learning and other is unsupervised learning. In supervised learning, you use models such as classification model, regression model, and within classification, these are some of the other models that are used: neural networks, Bayesian networks, decision trees, support vector machines. So in some of our courses that we teach, which Amit and Brian are going to talk about, they use some of these classification and other techniques to help students understand and do a better job in either prediction or prescriptive analytics. And then unsupervised learning is where you don't make any assumptions of the model and you try to use models which derive patterns from the data, like association rules or clustering, just based on the different patterns of data using analytical techniques. Okay, then this next two slides are going to talk about some of the models or standards that are used to create business analytics, solutions. The first step that anyone who's working in this area has to understand the business and the problem. Okay, before you jump into any analytics, you need to understand what this business is in, the context of the problem, as well as what are some of the issues here that the managers or company owners are facing in that area. Then the next step is on understanding the data. Okay. Once you understand the problem, you need to understand what data is available, in what format, can it be organized, cleaned up, and is there sufficient data to do analytics? That will lead you to the next step, which is preparing the data, where you get data in raw format and then you transform it into more useful format in terms of a data warehouse. Next, you would start based on the business understanding and problem, what models to use. Should we use supervised learning, unsupervised classification, because different problems will need different kind of analytics solutions. It may involve some testing, trial and error at this stage, because it's still art and it's not, perfect science yet. But that will come out through testing and evaluation, which is the next critical step, where you start testing your models with the data and see if the results that are coming out are matching the results that a human would make based on past data. And then once the testing is done, you start evaluating it with the newer data that is coming out from the organization to make sure your models are working. And then once you're satisfied with that, you go into deployment. The same steps are shown in a visualized manner here. The critical part is it's not a one-way direction. It's back and forth. You may do a little bit of business understanding, data understanding. You may have to do back and forth until you perfect the model before you deploy. All right, so that was a little bit of background on business analytics. Hope it has helped all of you understand what business analytics is about. Of course, in half an hour, it's a broad area, so we have not covered everything in detail, but it at least gives you a high-level overview. Now, the purpose of this webinar is more on teaching business analytics. So this session is going to focus on that. How business analytics is taught, both in general in other universities around the US and also at UMass. So here there are two pictures of our students presenting their projects either through posters or through presentations. At the end of their program, they work with a real industry problem using the steps we saw in the previous slide. And then after they solve the problem, we invite the business and they make a presentation on our capstone project, which I'll talk a little bit about later. So in terms of analytics programs or business analytics program in US, it's become in the last 10 years, one of the fastest growing area of growth in higher education in general and also in business. There are over 250 programs now in business analytics, or it's also known as data science in some universities in the US. Now, this slide here, there's a link here which takes us to this website, which is organized by the University of North Carolina. Institute of Business Analytics, and it gives you a lot more detail. So I'm assuming you will have access to this webinar later. We won't have time to show you all the details, but you can find out a lot of details about different programs. They even have an interactive map here, which you can click on it and expand and look at your favorite universities. And it has categorized these programs by these colored dots into analytics, business analytics, or data science. So by moving your cursor or expanding this map, you can get a lot of details about this program. For example, you want to see more about our program, you would zoom into Massachusetts, and somewhere here we have UMass Lowell, and we have Merrimack College. So these are the different programs in different universities by state. Then if you go down further on this, you'll see a lot more details about growth of analytics, and so it's a very useful website to get more details about the business analytics programs, how they're taught, curriculums. You'll see a wide variety, because this field is diverse. As you can see, degree programs can be categorized into data analytics, business analytics, or data science. And it's also very interdisciplinary character of this whole business analytics and data science field. You need expertise and faculty from applied mathematics, statistics, computer science, and business disciplines. But as I mentioned, it's growing fast. There are 8 to 10,000 graduates per year. And also the job market for data scientists or analytics people is very rich and diverse these days, and a lot of demand for them. So this is again a link here, which will take you to this website, which shows data scientist jobs. Okay. Again, it's from that same institute, and it shows you details about the kind of openings that are there in US. This is all US based, but I'm sure it's similar in India too, and there might be similar statistics available for you, in the Indian job market or wherever you are, China or other countries. Unfortunately, there is no such global thing which we can show you at this point. But there are a lot of these nice slides here and data about jobs which can be used to create growth. Moving on, the next slide. Now coming to a program at UMass Lowell. In 2016, we started this program, Master of Science in Business Analytics at UMass Lowell. Actually, the design and development of the program took 2 years almost for us, because it's a new field. And as I said, it's multidisciplinary. So we're trying to figure out how to put a program that does justice to all the disciplines and students who are coming in the program. So eventually it got rolled out in this format, where students have to complete 10 courses. 7 are required courses, and here we have each course is 3 credits, so 21. And then the importance of diversity was highlighted by allowing students to pick different tracks. And these tracks could be 3 courses in any one of the 5 tracks. Originally we had 4, and we have added 1 more. So there is big data track, decision making track, marketing, finance, accounting, analytics program. And as the students grow, we may keep on adding these new tracks, partnering with different departments, not only in our business school, but at some point we may go beyond the business school to our health area, to our science and engineering area, and create more tracks. The core courses that we teach in the program focuses on 2 major areas, which is the data management, and then the algorithm and decision analytics portion of it. So that's what you'll see in these courses. some courses focus on business intelligence, data mining, database management, which is the data part of it. And then the other folks focus on the models and like predictive.
You need to watch the time. Watch the time. Okay,
Sure. Moving on, so we'll give you some examples of 2 or 3 courses here, how they're taught, and then we'll end the session. So Amit is going to talk a little bit about his 2 courses. Go ahead, Amit.
Yeah, so one of the courses I here mentioned is what is called as business intelligence and data mining. So this is actually a course in our undergraduate, meaning the bachelor's degree program in business administration. And so this is a course that is a elective course that students enrolled in the undergraduate degree can take. And so some of these concepts that Luvai already mentioned, I'm not going to repeat them here, but these are covered in this particular course. And I use tools like RapidMiner and Excel, which are very easily accessible. For example, RapidMiner is a free tool, open source tool available that students, anybody can download. And we use that to do a lot of projects, which one of the nice things about this particular tool is that it is a code-free environment, meaning it is more of a drag and drop environment that makes it an easy starting point for a lot of students who may not be familiar with or may be apprehensive to using programming, especially in the business schools. So this is one of the key features of why I'm using RapidMiner and maybe used in similar other environments. The other only key feature of this course I just want to highlight is the hands-on environment, where we do assignments as well as the term projects, where we always use data from either open source, open access data sets like Kaggle is one website where a lot of data sets are available. But using data for every single assignment and a project gives the student a lot of experience on how to apply these concepts in real world. The second piece, the second data that or course I want to highlight is from our Masters in Business Analytics program. And this is one of the core courses, which is called Data Engineering for Business Analytics. And the core focus of this course is on how to bring in different kinds of data and also use different formats of data so that be able to spend a lot of time cleaning it. Because in reality, when you start working with any sort of data, the data is not in a nicely tabular formatted version that you can start immediately doing modeling and so forth. So we have actually spent a lot of time in creating this course where students get to work with messy data and working on ideas like how to use shell environments, which may not be easily accessible on many meaning if you're working on large data sets, you cannot actually open it on Excel spreadsheet. So you need to be familiar with shell scripting a little bit to do that. And similarly, we also introduced Python as one of the tools so that it allows students an introduction to using data using these tools like Python. So it's a tool that or course that really focuses on handling data in a variety of different ways using languages like Python and shell scripting. So I'll pass it over to Brian, who will talk a little bit about his course.
Hi, this is Brian Lee. So my course is Advanced Statistics for Business Analytics. So the emphasis of the course is to let the students understand how to interpret the models, and because most of the analytical tools are focusing on the predictive part and not necessarily ask the users or ask the analysts to understand the business scenario. That's why in this course, what I was trying to introduce is something called time series modeling, and I also incorporate with some other analysis. So the goal of this course is hopefully is going to be more practical oriented and focus on the application of using these statistical tools. And I use R. R is an open source software. And so this is free for everyone, and I think it is also a very powerful and very popular tools among the practitioners as well. So I have so the course is a 3 hours course for 15 weeks, and we have a project as well as 2 exams. So I should probably save some time, and I will let you guys ask a question after the seminar.
Okay, thank you, Brian. So the two courses give you flavor of two different areas. One is data mining or data management, which Amit talked about, and then also Brian's course, which is more analytics oriented. What I teach is at the end of the program, in our master's program, students have to do project, as you saw the picture at the beginning, where they, after they've finished all these 8 or 9 courses, they come to this final semester project where I connect them to industry, businesses in our area, and they have to work with that business from start to finish, going through all the 5 steps that we talked about, for project management, talking to the customer, determining the problem, and then analyzing data, getting the data, so on and so forth. So the goal of this, as you can see on the right, is to take the classroom knowledge and apply it to industry problem solving. That's what the goal of this capstone project is, and they work in teams, and they work over a period of 6 months with the industry sponsor to solve their analytics problem. So they get to apply what they've learned in real world environment, working with real people. This is our goals of the project, and each team has 2 to 3 students, and they have to go through certification, sign NDA agreement, define problem, and then work with the data. And then the key part of this course is soft skills, how to present and communicate through presentation. So we have a big presentation, as you saw in that picture earlier. They have to not only present to the company, but also other guests from different industries who will ask them questions, and they have to provide their results in an easy, understandable form and written report. So now we end the presentation. The next 10 or 15 minutes, we can hope to get good questions and answer any of the issues that you have.
All right, great. So Ashwin, you want to comment
yes.
on that?
Yes, you can you see my screen?
I'm gonna give you this. Give you the screen. Just a minute. Yeah, go ahead, Ashwin. Click show my screen.
So thank you, Luvai, Amit, and Brian for an exciting and interesting webinar or discussion on business analytics. Just want to let you know that we have very interesting webinars coming up in the next 2 weeks. One is next a week from today, biomimicry, quite an interesting topic, how to teach entrepreneurship through the nature. And the second one is the 2 weeks from today is the social media creating new possibilities for entrepreneurs. So do plan to attend. We will be sending you more information about these 2 webinars. And I thank you so much for your attendance. And now
questions. Let's ask
any questions.
Yeah, anybody have questions? We have time for some questions. So we're going to wait while you pop up questions. I realize that a lot of this, this subject matter is from the business school, business and management school, and some engineering faculty may or may not be familiar with this way of looking at data. And although in computer science they might be using some of the same tools, so let us hear some comments and questions from the audience. I hear a few things coming down the line. Once in a way, a little few of them. There's a Vijay Kumar says excellent presentation. That's good. Praveen says if data size is small, how to process it to big data?
Okay, Amit, you want to answer that?
Yeah, so if I understand the question correctly, it's the question is if the data size is small, how do you use big data tools? Is that the question?
I think that's what it is. Yeah, I think that's
yeah, no, I think, yeah, if the data size is small, I think we basically use tools that are suited for that particular data set, right? So essentially, good understanding of mapping between the kind of data and the tools is very important. So it's not necessary that you always use big data tools for analytics, right? So I mean, you might be so if you have a data set that is really small, Excel might do the job to create the reports and charts that you need. And even Tableau actually is fantastic, whether you are dealing with small to medium sized data sets, which is very useful in creating visualizations. So if you go to tableau.com, there is a Tableau desktop tool that is freely available for educators. So you might want to explore that option. But yeah.
Okay, next question from Felix. It says, for learning data analytics, the data on MOOCs that are available, massive open courses and online education tend to be very complex. Your reflections on how to make it possible, for example, regarding experiences of how to learn data analytics.
Right. I think you have a good observation. So I think a lot of these MOOCs or like Coursera, they are freely available, but they are also coming at it more from either a computational science or computer science perspective, which means that their focus is on understanding algorithms and the math behind these algorithms. So yes, they are kind of hard to consume for somebody, especially coming from a business background. I personally feel that as an educator, you have to be a lifelong learner, which means that you basically I myself taught the data science or analytics to myself by going through some of these books, which are not as technical, but more by picking up a tool and trying to learn the algorithms myself. So as an educator, that would be my advice. But when it comes to actually teaching, also taking that same approach when you are translating that to students, using more hands-on approaches by using tools would be a good way.
I think better than MOOCs would be online programs. I forgot to mention, even our MSBA program from next year is going to be fully online. So there are many such universities offering these certificate programs or full level programs which are online, but they also have interaction and, as Amit was saying, project-based, solution to the analytics problem.
Okay, good. One Vishwanathan is asking about a video recording. Yes, we will be sending out the video recording to all those who have registered. So thank you for that question. Another question from Felix is, which part takes more time and effort for analyst? Data pre-processing or processing or visualization/presentation?
My guess is, from my observation with all these capstone projects, 70 to 80% of the time goes in understanding the problem and then data cleaning and data readiness.
Yeah, the data modeling, I would say, is fairly, to some extent, a fairly straightforward or streamlined process. I mean, there are experimentation that goes along the way in modeling as well, but at the same time, there is more science to it. But at the same time, as Luvai was pointing out, the data cleaning, bringing it from various data sources takes a lot of time. And also similarly, preparing the visualizations and dashboards, I think as long as the data is cleaned and pre-processed properly, that process of creating visualizations becomes much more simpler. But also the knowledge of the tool is essential as well.
Excellent. Other comments, questions from the audience? Come on in, folks. We've had about 50 people here listening to you. So let's see what, give them some more time to reflect on. I think it's fascinating, the parallel between what you're talking about here in terms of, just a comment from me, in terms of taking a real world problem. And then I think the biggest challenge is take the real world problem and figure out what data you need to collect in order to eventually make decisions. And I think that takes a lot of time. So just like in engineering, a real world problem, you first need to figure out what question to ask, what problem to solve. And then you get into the using the technical tools to actually solve the problem. So the whole aspect of real world engineering, real world business management is something that you're doing a great job in your project and your courses.
Yeah, I mean, there are two areas of skills that any person needs in this area in engineering and all. One is the soft skill and one is the hard or technical skill.
Mhm.
So the soft skill is sometimes very critical, especially for people coming from engineering, science, and other backgrounds, and even sometimes in business, because they may have not been exposed to business conditions and business environment.
Mhm.
So understanding in different areas of business, there are different issues, and highlighting some of the critical problems before you jump to any solution is very important.
Okay, looks like we've run out of steam here. I think even though we had this at a later time in India because of our time change here, we still get quite a few people. So thank you all for joining, and thank you Ashwin, thank you Amit, thank you Luvai, and thank you Brian. This has been a fascinating presentation.
Thank you, Krishna,
giving
for
us the
all your
opportunity.
support. Thank
Thanks,
you
everyone.
all.
Bye.
Bye.
Bye.